Hello, for this lesson, we're going to talk about the integumentary system. The integumentary system we typically think of as our skin, and the integument is going to have a lot of functions in our body. One of the most important, though, is it is a physical barrier protecting us against pathogens. Pathogens, of course, are any kind of foreign invaders that are hoping to get access into our body. They could be a bacteria, a virus, a fungus. There are many different types of pathogens, and again, our integumentary system is going to be a barrier against these pathogens getting access to our body and causing us to have an infection. We typically just think of the skin as being what we can touch on the outside of the body, but in all reality, the integumentary system is made up of the epidermis, which is the outer covering, the dermis layer, which is a thicker part that has organs in it such as blood vessels, nerve endings, hair follicles. And then below that we have the adipose layer. That's a layer made up of fat. The epidermis is 5 layers or strata thick. The layer closest to the dermis is called the stratum basale. Stratum precedes each one of these terms. So stratum basale is this layer right up against the dermis. That's where new cells are going to be generated. And each time a new cell goes through the cell cycle and divides, creating 2 equal daughter cells, one of those new cells stays right down here at the stratum basale. So ultimately, those cells are completely replenished on a regular basis. The other cell starts to make its way up towards the surface of the epidermis. It goes through the stratum spinosum, the stratum granulosum, the stratum lucidum, and finally, the outermost layer of the epidermis is called the stratum corneum. As that cell makes its way through these different layers of the epidermis, it actually dies. It gets rid of all of its organelles and it can't replicate anymore at this point. It fills with a hard protein called keratin. That keratin is going to help us basically be armor. It gives us the ability to be watertight, so if we get into water, we don't take in water unnecessarily. But more importantly, since the human body is 70% water to begin with, it makes sure that we don't lose water to the atmosphere. It also, this keratin gives us the barrier that I was talking about to protect us against pathogens. It protects us against abrasions. So ultimately, this stratum corneum is about 20 to 40 cell layers thick of nothing but dead cells. Skin cells that ultimately were just simply filled with keratin and there to protect us. Most of the dust that you see in your house, those are actually dead skin cells because we're constantly sloughing off this outermost layer by a means to protect our body. And so ultimately, the epidermis, all of those cells, as they age, move towards the surface in an effort to better protect us from pathogens. If somebody's in the healthcare field and they are doing clinical activities and they need to wash their hands, the reason washing one's hands is so effective as a means of hindering the transmission of pathogens is because when you use soap and water and friction, you are sloughing off a lot of those dead skin cells and pathogens get down in there. And since it's dead skin cells and you can slough them off, you're sloughing off the dead skin cells and potential pathogens which could transmit disease. So this is our epidermis. It is going to be on top of the dermis. And the dermis layer has connective tissue. It also has all of these structures and more that I've put on our little diagram here. There are nerve receptors. Okay, it gives me the ability to pick up something as fine as a pin, roll it around, and if it's a pin, like a needle I should say, you can even thread it because we have these receptors that give us so much sensation to manipulate our environment. We have blood vessels, we have arteries, veins in our dermis layer. They're going to help nourish this dermis layer and protect it. make sure that it has all the nutrients it needs, make sure it has the oxygen that it needs. We have sebaceous glands attached to hair follicles. The sebaceous glands are going to be important. They secrete an oily substance called sebum, and sebum is going to be excreted into the hair follicle. It's going to lubricate the skin and keep it moist, and it's also going to lubricate the hair shaft as it grows and make sure that our hair stays moist, because hair cells are going to be dead cells too. Okay, they start out as live cells in the hair follicle, but as they get above the epidermis, those cells are dead too. So keeping them moist keeps them lasting as long as possible. The blood vessels in the dermis layer serve a lot of purposes. They're going to nourish the cells that are in the stratum basale, but once the cells move away from the stratum basale, they're away from their blood supply because the epidermis is avascular. There is no blood supply to it. So as the cells get away from the stratum basale, there's no nutrient value, no oxygen getting to those cells, and therefore that's another reason that they die, as they're filling up with keratin to help protect us as our body armor. But the integument with the dermis layer being so vascular, that serves a lot of other purposes as well. It can help cool our body. If, for example, it's very hot outside, our body can perspire. We have sweat glands. With openings to the top of the epidermis. And when we secrete sweat, that evaporates out into the atmosphere and it cools our surface. Well, these blood vessels that are in the dermis are relatively close to the skin surface, and they can actually dilate and get closer to the skin surface. So as the skin surface cools off, it cools the blood in those dermal blood vessels. Ultimately, that cooler blood gets circulated throughout the entire body, cooling off the entire body. Okay? Just the opposite can be said if it's cold outside. These vessels can constrict, keeping blood flow as far away as possible from the surface, and therefore keeping the body warmer. If somebody has a respiratory disease like chronic obstructive pulmonary disease and their oxygenation is poor, you will see it in their skin. Okay, they'll kind of have a grayish bluish tinge to their skin. And the reason why is the body has to make a decision where this precious oxygenated blood is going to go and do the most good when it's limited because of a respiratory disease like COPD. And one of the areas that the body will shunt oxygenated blood from is the dermis layer. Ultimately, more oxygenated blood, therefore, is allowed to get to the brain and to the heart, and since it's in short supply in a patient with COPD, that's important. And so keeping the blood out of the dermis gives them that odd color, that grayish bluish color, but nevertheless, it is a protective mechanism in that regard. Cyanosis, cyano means blue. The suffix osis is a condition of. So a condition of blue. So you would say somebody that has COPD is cyanotic. Okay? They have a blue color to their skin. And again, it's because there's a lack of oxygen in the blood that's close to the skin surface in the dermis layer, and ultimately that shows in their skin tone. We also, in these layers, have our melanocytes. The melanocytes are going to secrete melanin. That is a pigment that will add color to our skin, a brownish, blackish pigment color to our skin in reaction to UV light. So it's a protective mechanism against the sun's harmful UV radiation. Now, our integumentary system also serves another important purpose. It actually can help us make vitamin D, which is essential for the absorption of calcium. When our integument is subjected to UV radiation, we convert a precursor into vitamin D, and again, that helps us with calcium absorption and ultimately keeping our bones dense and utilizing the calcium for muscle contraction and other important functions in our body. The last layer of the integument is the adipose layer. And the adipose layer, made up of adipocytes or lipocytes, adipo and lipo are both combining forms that mean fat, and this is going to be our site for storage. If we take in extra calories, those extra calories get stored in this adipose layer. Okay? If we have certain medications or certain vitamins, known as the fat-soluble vitamins, A, D, E, and K are fat-soluble vitamins that actually can be stored in the adipose tissue. That's why it's important not to take too many supplemental vitamins, because too many of these fat-soluble vitamins ultimately could be stored in this adipose layer and later down the road have harmful effects on the body. But the adipose layer, it also serves as insulation. It keeps our internal core temperature regulated. It serves as cushioning, and it's very important to our functioning. People give fat a bad rap, but in all reality, it's essential for our body. It serves a lot of different functions. But this is an overview of the integumentary system, the epidermis, dermis, and the adipose layers, their overall function and protection from pathogens, protection from dehydration, protection from abrasions and other injury to our more precious, deeper tissues. So ultimately, this is going to serve in many roles, and it's our largest organ in the body, not only because of the surface area that it covers, but just due to that surface area, it weighs a lot more than any other organ in the body. So the integumentary system is our largest organ.